Hello, David Small here with Team Small Robots, and today we're going to start something that I've been wanting to do for quite a while now, and that is Fusion 360 tutorials, specifically Fusion 360 tutorials for making combat robots. So a bit of a disclaimer, this is a tutorial series specifically for building a combat robot. It does not cover every single feature that Fusion 360 has, nor does it go completely in depth of what it can do. If that is what you're after, I'd recommend checking out Lars Christensen's channel. I'll link that in the description. But if you do want to see what goes into building and CADing a combat robot and you want to follow along through an example, you've come to the right place. It's also worth mentioning that CAD design has some elements that are up to the individual user. Certain techniques are preferred or not preferred by certain CAD designers. So if you think of a way to approach a problem that's different, you should totally try it out and experiment. And of course, I'm not all knowing in what I do. If you have a suggestion for how I could do my techniques better, you should totally leave a comment for that as well. So with all that out of the way, we are ready to get started. So as you can see here, we're going to be making our own little Foxic, aka Predator, aka Foxtrot replica, or rather a Foxic inspired plastic ant, since it isn't a one-for-one model or anything like that. So if we take a look at this guy, you can see we've got the lifter, we've got the wheels, we've got the cool side panels, we've got the weird fur pattern thing. I'm not sure what that is referred to as, but we can even take the top off and take a look at the guts inside of here. You can see we've got our power switch, our battery, receiver, servo, our regulator, speed controllers, and one neat little feature is that the lifter is actually fully functional within the CAD design. And the best part of all of this is that this is fully parametric. Parametric modeling is a modeling technique that uses parameters, so parametric parameters, that's where that comes from, variables in other words. I can do something like maybe make the width an inch wider, and the entire thing rebuilds itself all automatically without me having to redo any of it. I don't have to reposition anything inside. I don't have to reposition where the motors go. I don't have to change where these extrude out from. It does it all for you. And that's what makes Fusion 360 stand out so much in the world of free CAD programs, is the ability to model things in such a powerful parametric way. So let me put that back. So it truly is a fully fleshed out CAD design, and it can be your fully fleshed out CAD design. All you need to do is follow along at home. So without further ado, let's get started on part one of our Foxic Plastic Ant CAD-A-Long. So in part one, we're going to cover the following things. We're going to go over how to install Fusion 360 for free as a hobbyist. Then we're going to explore the user interface. Then we'll create our first project, get started on the chassis, and then create some of the inner components. So let's jump right in and download our CAD program, Fusion 360. So here I am in my internet browser following the link that I have in the description. You do not want to click subscribe because that'll put you into a monthly subscription that you have to pay for. You don't want to do free trial either because that will make you use it for free a little bit and then you'll have to pay for it. Commercial subscription you have to pay for. Startup use you have to pay for. You want to click down here on, just kidding, that is also commercial subscription. All the way at the bottom here we have Activate Fusion 360 for personal use, and that is what we want to click on. Then once on this page, if you already have an Autodesk account, go ahead and use that, but otherwise you will create a new account, you'll fill in your information, and then it'll take you to this page, hopefully around here. If it keeps you up here, just scroll down and you'll click Download Fusion 360 for personal use. So that'll start downloading. Go ahead and click it when it's ready, follow the instructions, and then once it's ready, go ahead and open up Fusion 360 and we'll get started and look around. All right, welcome back to Fusion. So you'll see something kind of like this. Obviously yours will be empty. You won't have any projects open or anything like that. But I think it's easier to explain some of these concepts when there's something already here. So here we have our data panel toggler. That's kind of like our project explorer. Different projects will go in this window here. We can close or hide that as we wish. Then we have our typical file menu, save as, save new, open, blah, blah, blah. Then we have our toolbar up here with all of our various tools. On the left here, we have our browser. This is kind of like a file explorer on your computer. We have folders, and instead of files, they're components. And inside of components are more files and more folders. So we can look at document settings here. This changes if we want to use inches, millimeters, meters, whatever as our default unit. I'm going to keep it on inch. You can change it to millimeter if you want. Then we have our named views. We're not going to bother with any of that. Origin is the, your center in 3D space. You got your XYZ, your various planes. Joints are when you stick components together. So you can see where all those guys are. I usually keep that off unless I want to find one because, they're a little annoying and they get in the way. We have our sketches, and then we have our actual components. So we have our chassis, we have the drive system, we have the weapon, electronics, screws, and the top. So you'll notice when you hover over these, this little thing appears, and that eyeball or radio button is what is the active component. So if I were to check this, now our chassis is the active component, and everything else kind of fades away so you can look at it a little bit better. Whenever you're adding new features to your design, it'll show up in the timeline of whatever the activated component is. So it's really important to make sure that the component you're working on is activated. We'll talk about that more later. Then we have the eyeball over here. So let's say we wanted to hide the chassis. We could click the eyeball there. It disappears. We can make the top disappear also. And we can look inside and check out what's going on. If we open up one of these, you can see that we have more pieces inside. So inside of top, I have a top panel, another top panel, and then these are the various screws, and I just keep that all in the top section. So it's important to stay organized, use folders, that way you don't have a million different components on your sidebar here. Now if we go down to the bottom, we have our timeline, and this is every single action I took in making this robot. So every time I made a sketch, every time I extruded something, every time I added a fillet, anything like that will show up in this timeline. And then we can even, we can go down here, right click a random one and roll the history marker here. And this will take us back in time to when I only had this much of the robot done. Then we can use these buttons to step ahead, and it shows every step that was done to create this robot. You can even click play here and it'll do a little animation starting from the very beginning all the way to the end, step by step, of every single feature that I added to the robot. And that's pretty neat. And then we can use this button to go all the way to the end of time. So here we are, back to where we were originally. So now let's talk about exploring our design view. So I'm going to take my mouse here, and if you're using a trackpad, you're going to have a bad time. Please go out, get a $20 mouse. You'll be much happier doing this. So I'm going to hold down the middle mouse button and then move the mouse around, and that lets me pan around my design. Then I can hold Shift and the middle mouse button, and that lets me rotate and orbit around the design. Whee! You can also use the cube up here. Clicking the home button puts it at your home view. So you can click on top if you want. Look at the top, look at the front, look at the left, look at the corner in between the two, all that good stuff. Now you may have noticed that the scrolling is backwards. It's a personal preference sort of thing. If you don't like that, click on your name, go to preferences, and then in this menu here, you'll go down to reverse zoom direction and check that, or uncheck it and adjust it to however you like it. And with that, I believe we are finally ready to get started actually making something. So let's shoot on over here, go to our home section, and we'll do a new project, and we will put in the name of our project. So it's Foxic, but it's an ant, so Foxint. Let's open this guy up, and we'll do File, New Design, and here we are. We'll close this one out, because we are all about our brand new design here. So we will call it Foxint V1. And you can see here inside the Project Explorer, the file has been added to our project folder. So now we have our blank canvas. We can get started on making the chassis. So the very first thing you want to do when opening a new file is ask yourself, are there going to be multiple pieces or just one piece inside of this file? So we're going to have multiple pieces, which means right off the bat, we're going to want to create a new component. So let's right click this guy, new component. That's how I brought that up. Then we'll double click on it so that we can change the name, and let's call it chassis. Then we'll right click it again, make another component, and let's call this one electronics. So now we have two pieces of our robot. Now it's important to make sure you have activate component on the correct component that you're working on. So if I were to be working on the chassis and I added a sketch and I started doing stuff in here, make a little cube real quick, and that's my chassis. If I look at the timeline, you can see I created a sketch and then extruded it. But if I wanted to know specifically what did that, I would click on the activate component here, and there's nothing in here. That's because I had the wrong component selected when I made that sketch and did that extrusion. So I'm going to go ahead and delete those real quick. And with the correct component activated, let's make a new sketch. So we can do that a few different ways. We can either use the create sketch button up here, or we can push S on our keyboard to bring up the shortcut menu. Then we can do create sketch from there, or we could type sketch and then do create sketch that way. So the next thing we're going to do with the sketch tool selected is pick which plane we want our sketch to appear on. So the way sketches work is you draw it out and then you'll extrude it to create a 3D object. So I'm going to choose the bottom here. That way we can CAD sort of like a top-down view and then extrude that into a 3D object. So with the sketch now created, you can see we're in the sketch menu. We have all these different geometry tools and constraints and a sketch palette over here on the right. So we're going to make a box basically. So I'm going to push S on the keyboard and I'm going to use this center rectangle. If you don't have that there, you can type center rectangle and it'll appear. So we'll click on that. The first thing we want to do is create where we want our center point to be. So there's not really anything going on here except for the origin. So we're going to go ahead and put our rectangle there. Then I'll move the mouse to kind of get an idea of how big we want this to be. So something like that roughly. And I'll click again to confirm it. Now the rectangle tool is still active. So if I were to click again, it would make another rectangle. I don't want to do that. So I'm going to hit escape on my keyboard and that'll let us use our mouse normally to click on various pieces of geometry. So we have this cool little box. The lines are all blue, as you can see, and blue lines mean that they are not constrained. We can grab them with our mouse and move them around and stuff like that, and that is not what we want. We want every sketch we make to be fully constrained or fully defined, and that means the lines are black. So how do we make the lines black? We do that by constraining them. We can do that using various things up here or adding dimensions. So let's add a dimension to this line. I'm going to push D on my keyboard for dimension. You could also use the button there. And I will click on the line that I want to define. Then moving the dimension to where I like it, I will click again. And now we have a little box that's asking how wide do we want the line to be. So I'm going to type 3 and hit enter. And we have a cool little line. Now 3 what, you might be asking. We are looking at 3 inches because that is our default unit. If you had millimeters as your default unit, it would be a 3 millimeter long line. But even though inches are the active unit, I can change this to millimeters if I want. That makes a really tiny square. You can type all sorts of different things in here. You can do 3 inches like we did earlier. You could do a decimal like 3.5. You could do a fraction like 1/2. You can do a decimal like 0.75. You can even do a mixed number like 3 1/4. And pretty much anything you type will appear as a value in inches. So let's put that back to 3. I'm double clicking on this, by the way, to edit it. And then I'll push D again to define this line as well. And we'll also make that 3. So with those 2 dimensions, you can see that our square is fully constrained. I can't grab and move it around anymore. And that's exactly what we want. So let's make this a 3D object. We can do that by pushing the E key on the keyboard for extrude, and it automatically selected the profile I wanted, but if it wasn't selected, you just have to click on it. And I will hold down shift and the scroll wheel again and move my mouse so you can kind of see what's going on here. And this little arrow appeared that I can grab, and when I move it around, it creates a 3D object using that sketch as a base, and then this extrusion kind of determines how tall it's going to be. So once again, I'll type 3 in here and hit enter, and you can see I made a cool little 3 by 3 by 3 cube. You can also take a look down here to the timeline and see that the sketch and the extrusion that we added are in the chassis. So that's all pretty cool. Now, what if we made a mistake? We want to go back and change the size of this cube. Well, we can go back to our timeline, double click on the sketch, and it puts us back into that sketch. So maybe we wanted a 2.5 inch wide, I can't type, 2.5 inch wide rectangle and a 4-inch long rectangle. Then we can hit finish sketch again, and you can see it extruded it with that new pattern. So this is very handy for when you want to go back in time and make changes. Now, if you remember my timeline from the finished robot, you saw there were hundreds and hundreds of different objects here in the timeline. So if we wanted to make a change in something like this, we'd have to scroll and scroll and scroll, and it would take forever to find. So we're going to take this one step forward and add what we call parameters. So hitting S again and then typing change, we'll go to change parameters, and this will let us add some parameters to our project. So we'll hit the plus here to add a new one. Let's call this inner chassis width, make that 3 inches. Then we'll make another one, inner chassis length, again 3 inches. No, let's make it 4, so it's a little different. And then another one, we'll call it inner chassis height, and let's just make that 1 inch. So now with those parameters made, we can close out of this box, go back into the sketch, and instead of typing a number in here, we can actually use those parameters. So let's do chassis inner width, chassis inner length, hit finish sketch, and then we'll change the extrude to use chassis inner height. So now we have a 3 by 4 by 1 inch box that is defined with parameters. So now when I want to change these, I don't have to dig and dig through the timeline. I can just go to the change parameters menu and I can edit these directly in here. So let's make it 5 inches long and make it 4 inches wide. You can see that they change all by itself automatically without you having to go back and find anything. And that makes changing things that you think have to be updated often very simple. So let's actually make that back into what's more realistic for this robot. So maybe 3 inches wide, 4 inches long, and we'll keep 1 inch tall. And now we have a neat little parametric box. Now this chassis is looking pretty cool, but the biggest problem with it is that we can't fit anything inside of it. It's solid. We can't actually get any parts in there. So we want an open box basically. So let's go back into our sketch and let's create what is called an offset. So pushing O on the keyboard lets me select a region, and then I can either make it smaller or bigger than what it was originally. I'm offsetting it into a different size. So you can see when you make the new offset larger than the original, it uses a negative value, and when it's smaller, it uses a positive value. So let's make this -1/8 of an inch, and you can see that creates a 1/8 inch thick wall around our chassis. Now remember, we named these parameters inner chassis width, so the space between the inside and the other inside on the opposite wall, not the space of the outer part. So that's why I called it inner, just for that clarification. Now I think the thickness of these walls are going to be something that I change often, so I'm going to make another parameter, and let's call it wall thickness, and we'll set that equal to our -1/8. Then we'll change this dimension to be wall thickness, and now we can change the parameter if we want to make this thinner or thicker. So maybe we change it to 1/4 later on, and it makes that wall thicker all by itself. So I'll put that back to 1/8 for now. Hit finish sketch, and you can see our box doesn't really look any different. So we're going to have to go back into our extrude, and you can see how it's extruding the middle part, but it's not extruding the outer part. So I'm going to click on the middle section to deselect it, and then I'm going to click on the outer bit so it extrudes only that part of the sketch. Then I'll hit OK, and now we have a cool little parametric wall that we can put all of our parts inside. The next thing we're going to do is add one of the electronic components to our robot, and let's start with the speed controllers. So I've decided to use the Nbots DESC just because this is a speed controller I like. There's a few different ways to import an external part. You can either download a CAD file of that part and import it, or you can use measurements provided by the vendor to make it yourself, Or you can, as a last resort, order the part and physically measure it and then use those measurements to make it yourself. So we're going to do the second option. We're going to head on over to Inbots' website, and if we find the speed controller, we can scroll on down, and then you can see here that we have the dimensions for the length, the width, and the height. So we're going to use those values to make our speed controller design. Now, when it comes to creating a lot of parts inside of Fusion, there's some debate as to whether you should have everything inside of one file or split as much as you can into separate files. I've kind of come up with my own rule, and I say if this part is never going to change size or shape, I'm going to put it in its own file. Otherwise, I'm going to keep it here in the main file where I can do all the parametric magic on it. So since the speed controller is an off-the-shelf part, it's never going to change size or shape. I mean, sure, a new version can come out years from now, but for the most part, it's not going to change. So we're going to make it into its own file. That way we can reduce some of the clutter of our main timeline. So I'm going to go up here to File, I'm going to do New Design, and I'll save it and call it Inbots DESC Standalone, and hit Save. Now you can see over in our Project Manager, we have another file in here. Now, earlier I said, what's the first thing you do? You ask yourself if there's going to be multiple components or just one component. So since we're just using one component, I'm not going to make a new one. I'm just going to use this as our parent component, and I will make a new sketch like we did before. I will use the S key to create another rectangle, and I will define these using the website. So I'm going to push D and define the length, which is 26 millimeters. Then I will define the width, which is 18 millimeters. And then I'm going to push E to extrude all of this up to 3.5 millimeters. And there we go. We have a super basic model of what our speed controller will look like. And that's as good as we need it to be. We don't need to see the individual transistors and the solder joints and anything like that. This box gets the job done. So let's save that. And then I'm going to go back to our Foxic project. And with electronics as our active component, I will just drag our speed controller into the project. And just like that, it is included. If we open up electronics, you can see that the Inbots DESC has been added. So it's giving us the prompt to kind of move it where we want. I'm just going to leave it towards the front and hit OK. Now with the Foxint as our active component again, so we can see everything, we have a box with a smaller box, but that is our chassis with a speed controller inside. So let's add a floor to the chassis. I'm going to do that by once again making sure chassis is the active component. We don't want it to be the parent component. We want chassis. And then I'm going to use shift and the mouse wheel to orbit around to the bottom, and I'm going to create a new sketch. But instead of using one of these default planes, I'm actually going to use the bottom of the robot itself as a plane. Now, this thing that just popped up is asking about this component that I moved. If I want to capture that position or ignore it, if I hit continue, it just bounces back to where it was. If I were to hit capture component, it would show up in my timeline as a move command. And since that's not important, I don't want it there clogging up space. So let's add a floor to this chassis here. So I'm going to hit extrude, and I'm going to select the outer border and the inner border this time. And now we can add a bottom bit to our box. So I'm going to make this 1/8 of an inch and hit enter. And now we have a little box for our speed controller to sit in. Now, once again, I think the thickness of this base plate is going to be something I change fairly often. So I'm going to make yet another parameter, and I'll call it top bottom thickness, because I think I'm going to use the same thickness for the top plates, and we'll make that 1/8 inch as well. So now let's re-edit this extrude to use top bottom thickness, and there we go. Now we have a parametric box with a smaller box inside of it. And actually, now that I see this thing, I think I'm going to go back to making this 3 inches wide. And as you can see, it's very easy to do and automatically updates for you. All right, so that just about does it for part 1 of this Foxic CAD-A-Long. I know we didn't really do much in this video except for make 2 boxes, but now that the intro stuff's out of the way, we'll be able to do more CADing per video. I'll probably make the videos a little bit shorter too. Now make sure you subscribe, that way you're notified next time the next part of the series comes out. And if you have any questions, also please leave a comment and I'll be happy to answer those for you. Also, if you have any feedback on the video/tutorial series itself, please let me know so that I can make these videos as educational and good for you as I can. And with that, I will see you all next time.